perpendicular distance formula. Why is the perpendicular distance formula important? Well, the reason it's important is if you have to find the distance from a point to a line. Now, obviously, there's lots of different distances you have. So whilst we don't necessarily say it, what we mean is what is the shortest distance from a point to a line, and that is always the perpendicular distance. Okay, so there's a point, there's a line. I've written it in general form. We want to find the perpendicular distance. That will be the shortest distance. All right, there it is in all its glory. Now you can prove it by drawing in another point on the line, creating a right angle triangle using Pythagoras, and eventually you would get that particular formula. But essentially all it is, have a look at the top. That's why we write the equation in general form, because we put it in general form at the top, but we substitute in the point, x1, y1. We make it absolute value because it could come up with a negative number, and we're talking about distance. On the bottom, that's the hypotenuse you're dividing by. So square root of a squared plus b squared, the coefficient of x and y. Why is that the hypotenuse? Because remember, the coefficient of x and the coefficient of y, that's to do with the slope, which is rise over run. That would be the adjacent and the opposite side. So therefore, the square root of those two things added together would be the hypotenuse. So that's where it all comes from. But that's all you really need to remember is, oh well, general equation, sub in the point, divided by the hypotenuse, you get your perpendicular distance formula. Find the equation of a circle. Hang on, how's that come into this? Tangent 3x minus 4y minus 12, the centre of the circle is 1, 4. You've got to remember a little bit of circle geometry to realise why this question is appropriate. Here's a circle. And the centre is 1, 4. I haven't bothered drawing up the axes or anything like that. There's the tangent, and we're saying what is the distance basically there? Because if we want the equation of a circle, we need the radius, and we need the centre. We've got the centre, we want to work out the radius. This is where circle geometry comes into it, because the radius is always perpendicular to the tangent at the point of contact. So in fact, we are finding the perpendicular distance of that point to the line. General equation, sub in the point, over Pythagoras. 3 minus 4 minus 12, well that's negative, but that's all right, absolute value. Oh look, the classic 3 squared, 4 squared, we know the answer to that. Pythagorean triad, 3, 4, 5, so it's got to be 5 on the bottom. What do we got? 25 over, well root 25 is 5, so we end up with 5 units. There's our radius. And now we can answer the question. The equation of the circle must be x minus 1 squared plus y minus 4 squared is 25. Now, what it does mean, whether this is useful or not, who knows? If we look at this formula, it tells us something. ax1 plus by1 plus c, when we substitute that in, sometimes we'll get a negative number, sometimes we'll get a positive number, and if it's on the line, obviously we're going to get the answer 0. So, depending on the sign, it can tell us which side of the line is the point. There's the line. On the right-hand side, if I said to you, shade the inequality where it's greater than 0, you would shade one side of the line. So, in other words, what we're saying is, if you've got a positive number when you sub in, you must be on this right-hand side of the line. And the other side of the line would be a solution to the inequality ax plus by plus c is less than 0. So, if you sub in and you get a negative number, then you know you're on the left-hand side. So if you ever had to prove for some reason that these points were on opposite sides of the line or on the same side or something like that, well, that's what you could do. You just substitute it in the general form. If they're both positive, they're on the same side. If one's positive, one's negative, they're on different sides. The next really useful formula. If I want to find the equation of a line that passes through the point of intersection of these two lines and another point, the long way of doing it's this, so without this formula. I would solve them simultaneously to find that point of intersection. So let's do that. And eventually we get that x is -2 and sub back in, I can get y is 3. Okay, I now have a second point. I've got 2 points, so I can find the equation of a line. So let's find the slope, there it is, -1/3, point slope formula, and we have our equation. Oh, it's not a lot of work, but we can do it quicker by using the magical lambda formula. So here it is. Now I've used k instead of lambda, but that's why it was called the lambda formula, because there was a lambda there as the constant rather than a k. You see, you've got two lines, and you know that any point on one of those lines will give you an answer of 0. And so the point of intersection, which is on both of those lines, must make this whole equation equal to 0. Doesn't matter what k is. So that we can create a line. There must be a value of k for which this will be true. And it's when these two lines go through the point of intersection at that particular point. So the first one, we know the point of intersection lies on that, so that will equal 0. The second one, we know the point of intersection of that lies on the line, so that will equal 0. Thus, it must be a true statement regardless of what k is. So therefore, I know the answer to our question will be in this form. My challenge is I just need to know what k is. Well, I know a point that is on that line, because remember, it also goes through the point 1, 2. So if that is the line, I just don't know what k is, 1, 2 must satisfy that equation. So I'll sub it in and work out what k is. Sub in 1, 2, and eventually we come down to k is minus 5 on 4. So there is the equation of the line. Now it doesn't look like an equation of a line, so let's make it look like one. We'll group like terms and we'll put it in general form, so we'll get rid of the fractions. Okay, collect them. Doesn't look like the answer we got before, but that's because we've got a common factor of 7 there. So divide 3 by 7 and we get the answer. That is a heck of a lot quicker than going to try and find the point of intersection and then doing all that. So just bang, put it into this. So it's sort of a similar idea to what we saw with the perpendicular and parallel, just using the pattern. We know it must look like this. So let's use that, the Lambda formula. Now I know it. Voila. So 17 to finish off. Look, I've also run off some past HSC questions there.